So in this case, we have an object that is on a flat surface. This time there is no angled surface, there is no inclined plane. However, the force is being applied at an angle. So for this problem, let's go ahead and assume a few things. First, that is accelerating to the right, and it's to the right because that's the direction of the force that's being applied to this object. The second thing is to assume that there's friction in this problem. So I'm going to tell you that there's acceleration and there's friction. Let's go ahead and set this up. We know that the weight goes straight down. We know the normal goes up. We know the friction is going to go this way. And the friction in this case is going to be kinetic friction because it's the friction is associated with Newton's second law. Now, when it comes to this force that's being applied, there's an x component and there's a y component. And this is the angle theta. If we go ahead and focus on this triangle for now, we'll note that sine of theta is the opposite, which in this case is Fy over the hypotenuse. So this is in contrast to the other problems that we did where the object was on an inclined plane. So this is why it's so important that we always set these up from scratch to make sure that we understand what the problem is demanding and that we are also aware of how the components are playing with the other forces in the system. We go ahead and multiply both sides by F. And we get these components. We're ready to set up Newton's laws for this object. We will identify an x and y axis coordinate system as shown. This is very convenient for us because it already lines up the normal force for us, the friction, the kinetic friction, and the weight. The only thing that is not aligned is going to be this force that's being applied. However, we've already made accommodations for that by breaking it apart into the x component and the y component. We note that the acceleration is going in the direction of the applied force, so the acceleration is going in this direction. As a result, I'm going to assume that going to the right is positive, going to the left is negative. I'm going to assume up is positive and down is negative. Let's begin with the sum of the forces along the y-axis. Now this box is not jumping up and down on the y-axis, it is moving left and right. So acceleration is happening along the x-axis, left and right. When we set up Newton's laws for the x-axis, we will be using second law. Because the box is not moving in the y-axis direction, we will be using first law. We will note, however, that we have a normal force going up and we have a vertical component of force going up. So I have a positive normal plus F sine theta and then minus the weight. I can rewrite this as normal plus F sine theta minus m times g equals 0. And I'll keep that ready and waiting. We can go ahead and set up second law along the x-axis because it is accelerating. We only have two forces. We have the horizontal component, which is positive, and then we have the friction opposing it, which is Fk, kinetic friction, and that's m times a. We know that Fk can be expressed in terms of the coefficient of kinetic friction and the normal force. And we know that the normal force, well, the normal force, we could get the normal force from here. If we go ahead and move all this to the other side, we get the normal force. And so that will go in place of the normal force. And so we get this relationship right here. It's becoming more evident why we spent so much time on Newton's first and second laws on the dimensions that we used previously. and how we really spent time on developing the idea of setting up free body diagrams, identifying positives and negatives, being comfortable with the relationship between mass and weight, and just in general being able to set things up, right? Balancing forces on one side of an equation and setting it equal to 0 if it's in equilibrium for first law, or setting it equal to mass times acceleration if it's second law. It's very important that you are comfortable with your trigonometry, sines and cosines. Those are very necessary for this class. And in this case, it was good to note that how it would set up differently if the object was not on an inclined plane but on a flat surface, and if the force were applied at an angle.